Hello, for today's video we'll discuss about algebra, a word problem. So the problem says, a group of tourists took a sightseeing bus trip of 240 miles and then boarded a plane which took them to their next stop 550 miles away. The average speed of the plane was 16.5 times that of the bus, and their travel was 6 hours and 50 minutes. Find the average bus and the average plane speed. So for this type of problem, we're going to illustrate it so we can visualize the problem clearly. So it says here that the trip took place in two different vehicles, a bus and a plane. So we draw it in a straight line. So this is the starting point, A, B, and C. So A and B will be the bus trip which took for 240 miles, the trip. Okay, so this one is for the plane, which is 550 miles. Okay, so it says here that the time traveled is 6 hours and 50 minutes. So this 6 hours and 50 minutes will be converted to decimal, will become 6.83. So therefore the total time travel is 6.83. Where did I arrive at 8.83? 50 minutes divided by 60 is equivalent to 0.83. Okay, so therefore the velocity of airplane, we plot the is from here, it's 16.5 times of the velocity of the bus. Okay, so very clear. So therefore velocity of the bus is equal to distance over time. So we're using here the basic formula of velocity, distance over time. This is what we're looking for. Okay, so velocity bus, the distance of the bus is 240 over the time of the bus. Okay, and for the airplane, velocity of the airplane is equal to the distance 550 all over the time of the airplane is 6.83 minus the time of the bus. Okay, 6.83 minus the time of the bus. Okay, we derive it here. This is the time of the bus, time of the airplane. So that's why the time of the airplane is 6.83 minus the time of the bus. Okay, so from these equations, okay, 1, 2, and 3, okay, we will derive the average speed of the two. Okay, so velocity bus, so from here velocity of airplane is equivalent to 16.5 times v of the bus. So using equation 3, so velocity airplane will be 16.5 velocity of the bus is equal to 550 all over 6.83 minus time of the bus. Okay, so I just replaced this airplane with this equation. That's why it's 16.5 v of the bus equals 550 over 6.83 minus time of the bus. Okay, so we cross multiply this one, so that will become 16.5. This velocity of the bus, I also replace it here, 240 over t of the bus, so I can get the t of the bus. So this one, you replace it with this equation 2. So 240 all over t time of the bus. Okay, so equals 550 all over 6.83 minus time of the bus. Okay, so clear. From here, from this equation, we have only one variable, which is the t of the bus. Okay, so we can find now what's t of the bus. Okay, so from here we cross multiply here, so 16.5 times 240 over t time of the bus, so times 6.83 minus t of the bus is equal to 550. Okay, so you multiply this one, 6.5 times 240 times 6.83, that will become 27,046.8 all over t bus. Okay, minus 6.5 times 240 times 3960, 6.83, that will become 3960. Okay, the t of the bus will cancel. Okay, equals 550. Okay, therefore t of the bus is equal to 27,046.8 divided by 3960 plus 550. So the t of the bus will be 5.997 hours. So that's the time traveled by the bus. Okay, so very clear. T of the bus, this one cross multiply there, this one transpose there, so that's why 27,000 divided by the sum of 3960 plus 550 equals 5.97 hours. Therefore the velocity of the bus is equal to the distance of the bus over time. So the distance traveled by the bus is 240. Okay, so divided by 5.997 hours, so the result will be 40. Okay, 40 miles per hour. Okay, so that is the result. So given that the velocity of the airplane is 16.5, that's why the velocity of the airplane is 16.5 of the velocity of the bus, so 16.5 times 40. So let's compute 16.5 times 40, that will be 660 miles per hour. Okay, so let me check 16.5 times 40. Can you check? So let's multiply 16.5 times 40, 5, no, 0, 0, 0, 5 times 4, 20, 24, 26, yeah, 660 miles per hour and 40 miles per hour. So that's the solution.